Okay, here we are. We're back at it. This is the lesson 9.4, 9.5, part 2 lesson. Still working with sine, cosine, tangents, our kind of introduction to trigonometry, right triangle trigonometry. So just rolling through what we looked at last time. If you need more detail, go back and watch the part 1 video. But basically everything was kind of centered on this idea of SOHCAHTOA, sine, cosine, tangent, and the ratio of side lengths in triangles, right? So sine was opposite over length over hypotenuse length, cosine adjacent over hypotenuse, and tangent opposite over adjacent. We were kind of using this this phrase, a silly phrase, to kind of remember what goes with what. Okay, so we used it. Really, I mean, the big kind of types of problems was, here's a right triangle. We don't know, we're missing one of the side lengths. We can't Pythagorean theorem. It's not a special right. It's not a 30, 60, 90. My only option really to find an unknown side length would be to use trigonometry. So we kind of put ourselves at an acute angle, labeled the sides. Everything was in terms of hypotenuse, opposite, and adjacent. We want to label our sides depending on where we're putting our little person. Decide, hey, I know opposite, I want to know adjacent. So that's how we decided on tangent. Tangent is opposite over adjacent. So I went tangent of 31 is opposite over adjacent. That's where this came from, what's in pink, and then the blue is me solving it then. So we said, hey, let's just turn this into a proportion. We can cross multiply, 1 times 17, x times the tangent of 31. This was kind of the two-step solver where I had to get rid of the tangent of 31 by dividing, and then that was my side length, about 28.3. Similar idea, we looked at in example 3, going back and using sine, cosine, kind of a little bit simpler solves because that x, that unknown, that y in this case, was in the numerator, so a little bit nicer solve. Really, the second part, it's still just building on that. Same idea, sine, cosine, tangent. So new for today, part 2, basically applying trigonometry to our special right triangles. So we had our special right triangles going back to lesson 9.2, our 45, 45, 90, where I had side length ratios of 1 to 1 to the square root of 2. Okay, and we use that in a variety of ways. Anytime we had a 45, 45, 90, we could find unknown side lengths by using proportions. Same thing with our 30, 60, 90. We knew that the short side, the short leg, had a 2 to 1 ratio with the hypotenuse. The hypotenuse is always going to be twice as big as the short leg. And the long leg, opposite the 60 degree, was going to be the square root of 3 times larger than the short leg. Okay, so we need to know those triangles for what we're going to do with the trigonometry. But basically, we're applying that SOHCAHTOA concept and taking it and really just kind of standing at one of these angles to give exact sine, cosine, tangents of some of these angles. So this is kind of it. We can use, that's basically what I just said, that we can use these two special right triangles and our SOHCAHTOA now to identify exact sine, cosine, tangent ratios. So we'll do a little mini example here, and then we'll look at kind of the first homework problems, what they'll look like. So our first, let's see here. The first thing, just like all the other problems from this section, I'd want to see that phrase, just so I can kind of, whoops. SOHCAHTOA, just to remind me of what goes with what, who's my, what are my side length ratios, and then I'm looking, all right, there's two things I need to know. What are we at? What's the question asking for? It's asking for sine, so that's already telling us we're going to be working here, and it's asking for a 45-degree angle. So I've got everything I need. We're going to stand. We put our little stick person here at the 45. Either one of the 45, doesn't matter. Here it's the same. And if I labeled everything, the side that's opposite of me is over here. The side that's right next to me would be my adjacent side, and then the hypotenuse is always the hypotenuse. Okay? So we'd look at the ones that we're interested in. Are opposite and hypotenuse. Okay? So the sine of 45 degrees, and it's a little bit different than the last couple because we know all the side lengths. We're not solving for a side length. We know them all. we're looking for what is actually the sine ratio. So the sine of 45 degrees is the opposite length, right here, opposite length, over the hypotenuse length. Okay. So that is what the exact sine value of 45 is. Now we've seen in previous lessons, say, well, we don't like that. We don't like that square root in the denominator. So we need to fix that. So our way of what we call rationalizing the denominator was multiplying both the top and the bottom. This is a good review for us. By the square root of 2, right? This has a value of 1. I'm not changing the value. So 1 times the square root of 2 is 2. And then the bottom we get square root of 2 times square root of 2, which is the square root of 4, which ends up being 2. So not all the problems will end up having to simplify, to rationalize that denominator, but this one did. It just kind of depends on, do we stick this square root of 2 or the square root of 3 in the denominator? It kind of just depends on what the question's asking. So the exact sine of 45 degrees is the square root of 2 over 2. So there's no calculator really involved here. And the hint there would be when it's asking for exact, this is our way of doing it. I could use my calculator to kind of check. If I ask my calculator, you can't see it right now, but I'm typing on my calculator, what is the sine of 45 degrees? My calculator says 0.707106781 continuous. Now, that's not exact. The square root of 2 divided by 2, if you had to guess, what's the square root of 2 divided by 2? Again, I'm using my calculator, the square root of 2, and I divide it by 2, I get that same number. It's 0.70710. So they have the same value, but this is exact. The 0.707 would be a rounding. Okay, so that's kind of the process. It's a combination of SOHCAHTOA along with our special right triangles. So let's do one here. Let's do another one. This is kind of what the homework will look like. So it says use a special right triangle to find the exact sine, cosine, and tangent of a 30-degree angle. Okay? So I think to start, there's a couple things that I'm going to need to see, that I'm going to want to see to do a problem like this. I'd be definitely looking at some point, whether it's the first thing I write or second, I need to see SOHCAHTOA, because, again, that's until I'm getting really proficient with it. I need to see those relationships. And for me, I'd also like to see just a sketch of our 30, 60, 90 triangle. Why 30, 60, 90? Well, because that's the one that it's asking about. It's asking about 30. We would use the same triangle if it asked about the 60. And then the big thing here would be to make sure we're getting the side length ratios in the right spots. Okay, so those are the two things I'd want to see before I start doing anything. From here, it's kind of what we just looked at. All right, let's go stand at the 30. Standing at 30 degrees. And in terms of where we're standing now, we're going to label all our sides. Here's my opposite. Here's my hypotenuse. Here's my adjacent side. And I think we're going to need all of them because the question's asking for what is the exact sine, cosine, and tangent. So it's kind of 3 problems in one here. So to kind of get it going, let's just go in order. Let's start with sine. So the sine of 30 degrees is found by taking the opposite length, which I've already labeled as 1, over the hypotenuse length, which is 2. And here's an example of one that there's nothing else to simplify. The sine of 30 is 1/2. No calculator needed. That's the sine of 130 is 1/2. Every 30-degree angle has a sine of 1/2. Next one. That was easy enough. Cosine. The cosine of 30 degrees is equal to, now adjacent length, which we're saying is the square root of 3. So adjacent length over hypotenuse length, which is 2. So again, we're kind of in that same boat. As long as we're putting that hypotenuse in the denominator, which is a nice even 2, we don't have that issue of rationalizing. So again, I think we're okay here. The only one that's going to be a little bit of an issue for this one, which still shouldn't be too bad, is our tangent. So when I go to look for the tangent of 30 degrees, we're talking about the opposite length over the adjacent length. And that is the value, but just like we saw in the previous kind of example, that we're going to have to fix this now by getting the square root out of the denominator. So it's a simple fix. It's always kind of the same process with square roots. To get it out of the denominator, create that perfect square down there. So top 1 times the square root of 3 is the square root of 3. Square root of 3 times the square root of 3 is the square root of 9, which is just going to end up being 3. So my final answer here ends up being the tangent of 30 degrees is equal to the square root of 3 over 3. So that's kind of the first type of problem. You'll see in the homework, I'm kind of asking for 60, for 45, some of the other sine, cosine, tangents. There's only really 3 angles we can do this with, 30, 60, and 45. So refer to this example, look at the rationalizing portion of it, but you shouldn't need a calculator for these ones. I like this section because it's kind of combining a few different concepts, the SOHCAHTOA concept, previous special right triangles, as long as some of that simplifying stuff that we maybe haven't done for a little while. So there's special right triangles and trigonometry. The last section, really, and again, it's kind of a shorter assignment in that we're taking this concept now and really extending it to trigonometry to some situational problems. So the biggest thing with word problems, with real life problems, is we want to have a picture that can assist us. You would think, or hopefully you would be thinking that we're going to still involve right triangles. Everything is involved as right triangles. So most in every case, you're going to end up with a right triangle. It just kind of depends on are we looking up? Are we standing on something looking down? Is it a building? Is it a house? Are we at the top of a tree? So there's lots of different things that we're kind of looking at. Usually the questions involve finding some height or some distance from an object. So the 2 vocab words that we're going to see that go along with this are angle of elevation and angle of depression. And they're really easy to get mixed up. So we'll do a quick picture here. Again, I would maybe add this to your notebook just so you have it to reference, so you don't always have to keep going back to the video. So the first one, the angle of elevation, refers to when you're looking up from the ground, the angle that you make with the ground. So I think the easiest probably enough just to do a picture here with it. So here's my ground level, okay? And let's say we have a building over here. We're looking up at the top of a building. There's the door, a couple windows. All right, and let's just say the angle, it would be worded kind of, you're standing X amount from the building and looking up at the top of the building at an angle of elevation of let's say 37 degrees. Okay, so where that fits into my picture here is I'd be standing, some distance away from this top of this building, and I'm looking up at the top of the building. The angle of elevation I would kind of associate with the ground, 37 degrees. A lot of people want to put it up here, but just because they see elevation, they think height. I want to put it up here. It's always angle of elevations with the ground. Okay, and if you can kind of see where this is going, you can see here's your right triangle. We would need to know some distance. If I walked it off, if I can't solve for anything right now with just an angle, I would need to know at least one length in this triangle here. But let's, if for instance it said you walked off 50 feet from the building, we could definitely figure out now what is the height of the building using opposite over adjacent. The tangent of 37 is x over 50. So that's, you can kind of see, but that's the trick, is making the picture, getting the numbers where they go. We'll do one after this. Next vocab word. The next word is similar sounding, the angle of depression. Okay, this would be normally your sight line looking down at an object. Okay, so this would look like, again, you can almost start with, let's do this a same type of picture here. Whoops. So we're looking at the ground level. we'll kind of put it in the same spot that we had the last one. So here's the ground level. Now, this time, we're standing on top of the building, looking down. So let's say I've got a little box on the ground right here. Here's a bowl. And however it's worded, you know, it's going to say the angle of depression is, let's use a different number, 41 degrees. Okay, it would say you're standing on top of the building, you're looking down at a box so many feet away, or something, some object, and the angle of depression is 41 degrees. So it's still going to involve kind of recreating that right triangle. It's close enough. There's our right triangle. We've got a 90-degree angle here. But now it matters, where does that angle go? The biggest mistake is it's still not right here. We never actually put this angle right here. Whether it says angle of depression or angle of elevation, we never put this one in. This one's tricky because it says the angle made with the horizontal line, or you can see my note down here, made with the horizon. So the horizon, remember, would be like parallel to the ground. So I know this isn't part of the triangle, but this would be like the horizon line, kind of a flat parallel line to the ground. So the angle of depression is this angle right here, which is tough because it's not actually part of my triangle. 41 degrees isn't involved in this triangle. Say, well, how does that help me? Well, now we can do certain stuff, because this right here, this 41 and this angle right here have to form a right angle, the building and the horizon. So I can go 90 minus 41 and get 49 for just this angle. It's not the angle of depression, but it's just, now it's an angle in my triangle that I know. I could also do this. This angle right here, if we're kind of making the assumption, which we are, that the horizon line and the ground line are parallel, this angle right here forms an alternate interior angle with this angle right there. So this would also be 41. So I think the biggest takeaway here is that really, whether it gives me the angle of elevation, we're on the ground looking up, or where it gives us the angle of depression, we're on the top looking down, that number ultimately gets kind of put on the ground as one of your acute angles in your triangle. So there's a little bit of terminology here, making sure that we're practicing that. Go back, watch this section if you need to kind of review those terms. Let's take a look kind of at the last example, and that'll be it. The homework ones will be very similar to this, where it's all words with no pictures, so it's kind of on us to make the pictures. There's a lot that we'll add here, so let's do it. You're on top of a roller coaster, 100 feet above the ground. The angle of depression, there we go, is 44 degrees. About how far do you ride down the hill? So this is one. If you couldn't tell from the last ones, I'm definitely someone that I think if I'm making a picture, I kind of want to make it, I don't know, maybe it's a little bit more fun to make it kind of accurate. Here's my roller coaster, and I'm going to continue from there. Well, where's my right triangle? We're sitting up here in the old roller coaster, right? These are all connected. We're sitting right at the top. Here's us, first car. Here's my right triangle. All right, let's say the ground is kind of the roller coaster comes right down to the ground. Here. So, again, do I need to make it that detailed? No, probably not, but I think it'll help kind of as we decide what we're even looking for. So we're sitting on top of the roller coaster 100 feet above the ground. That's stuff that I just need to add to my picture. This height right here is 100 feet. We're 100 feet above the ground. We know straight down to the ground would be a 90-degree angle. The trick is going to be, where does this 44 degrees go in my right triangle here? So we talked about the angle of depression being formed with the horizon. This is actually 44 degrees here. But what we had just talked about, that because these are alternate interior angles, I can move that 44 degrees to right here. So now I have a right triangle with a side length, with an angle measure. We could find this one, right? 90 minus 44, we could find that right there. We don't have to, because now we can use trigonometry to figure out what are we actually trying to find out about how far do you ride down the hill. So we're taking a little bit of liberty, I guess, depending on how accurate my picture was with the big drop right here to the ground. So we're taking a little bit and just saying, well, about how far, because it does say about. We're not finding exact here, but about this distance. What is this distance right here? So I'm going to call that my unknown. It could ask, what is the horizontal ground covered? There's different things. It could ask us for this length, and we could find this length. I think this is about how far we ride down the hill, though. What is the track length that we travel? So let's find it. Once we make the picture, it's really just more getting back into the part one portion of the lesson, where we're solving for an unknown using SOHCAHTOA in a right triangle. So let's put ourselves, kind of maybe a different person here, standing at one of our known angles. Okay. Whoops. Label our sides. So here's would be my opposite. I really only need to label. I guess we could label this one. It's not going to hurt us. But I really only am looking for the two that's going to help me. I know opposite. I'm looking for hypotenuse. So the one that involves is sine. So we're ready for a setup here. The sine of where we're standing is equal to the opposite length over the hypotenuse length. Okay, so that's my setup. The setup usually, it's not a ton of work. It's just getting the stuff in the right spots. Opposite over hypotenuse. The last part here is now, okay, here's the solve. This is going to be one of those two-step solves because I've got my x downstairs here. So when I cross multiply, I'm getting 100 equal to x times the sine of 44. And x is not by itself. Sometimes it is, not in this one. So we're going to have to divide both sides by the sine of 44, like we were doing a lot in the previous lesson. Sine of 44. This is going to get some cancel going on here. The 44, the sine of 44s are going to disappear. We're set up for x being equal to 100 divided by the sine of 44, which is going to be, and it should be a meaningful number. Again, it should come out to not these crazy small decimals. We're talking feet here. I'm expecting to be larger than 100 feet. I've got my calculator in my hand. I'm typing in 100 divided by the sine of 44. Push equals. My calculator says 143.95565. So to answer the question about how far do we ride down the hill, I would say about a 144-foot drop, or whatever you want to say. That would be the number that I'd be looking for. You could say 144 would be pretty close. So that's kind of the approach on the word problems. It's the same concept that we saw on the previous lessons as far as using SOHCAHTOA to finish it. Once you create the triangle, that's the hard part now, is you're using the vocab, making a picture, a right triangle picture. So in the homework, I want to see if there's not a picture provided, lots of pictures drawn. You can make them detailed. Maybe that'll spice things up a little bit when I'm looking at your homework answers. So there's two concepts that you're going to practice today. The right triangle, special right triangles and trig, and word problems involving trigonometry. So give it a shot, submit the homework, and have a great weekend.